Hello students, now we'll start the second lecture of unit and measurement, which is related to the accuracy, precision, errors, type of errors, propagation of error. When we discuss about the accuracy and precision, we are taking four figure here. Here one target is there. Suppose you are targeting this target value, this is the target, this is the target, and this one is the target with 6 flying bullet. Okay, in first figure your playing bullet is here targeted here, but targeting main target is here. Second figure all playing bullet are here. Third figure, here you see this is the accurate value, target value, but you are targeting here, and fourth figure is here. First is that low precision and low accuracy, different places. Now here it is high precision. Your target is here, but whatever you are targeting, all are the one place targeting here. And third figure, here you see this is the actual target value and targeting here. Okay, and here it is the low precision but high accuracy, close to target value, actual value. It is here you see close to actual value, and all targeted are very close. So it is high precision and high accuracy. So what is accuracy? Accuracy is the closeness of the actual value. Closeness of the actual value is the accuracy, and repetition is the happening. A repetition of the happening is the precision. Okay. So here you see this is precise, more precision but not accurate. So you can say if instrument is more precise, it is not accurate. Okay. So is there is an accurate, so we have to do the error. What will be the error? Error, obviously it is the whatever we are measuring, it is not actual value. Some uncertainty is there. Okay, uncertain. Error is the difference between the true value and measure value. Okay, so true value and measure value, error equal to true value minus measure value. Obviously if true value is greater than measure value, obviously this term will be positive, then it will be positive error. True value less than the measure value, it will be higher, then negative error. And if it is true value equal to measure value, then zero error. So here if you measuring one length, it is 10 centimeter. Actual length is 10 centimeter, but you are getting 10.5 centimeter. So what will be error? 0.5, and it will be measure value is higher, so it will be negative. Okay, true value measure value is higher, so it will negative error. Okay. Now what are the type of errors? Here type of error is basically classified 3 types: systematic error, random error, least count error. Systematic error, you see from the name of the systematic error, it is coming from the system. Okay, errors due to fault in the measuring instrument and experimental method. So it is classified 3 types. One is the instrumental error, personal error, imperfection. Here instrumental error due to instrument, poor calibration, wear and tear, design flaw. And how can reduce? By periodic calibration and higher precise equipment. Personal error, it is obviously due to it vary man to man. Okay, here careless reading, wrong data entry, improper apparatus calibration. This is a due one. How to reduce? Obviously you should be careful and follow the proper procedure. Okay. Random error. What is random error? Random error is the random. It will be happening. You cannot reduce this one. It is the unpredictable variation of measurement condition. Unpredictable. You cannot predict that one. Okay. And least count error. Least count error is the maximum uncertainty associated with the resolution of measuring instrument. Typically smallest value can be measured. Here it is classified 3 types of. One is the absolute error, mean absolute error, relative error. Absolute error. Now one thing I am explaining that Suppose this is the mean value, and obviously if it is mean, obviously sum is the right side, sum is the left side, higher than the mean value, lower than the mean value. Okay, so if you take the difference from the higher value, obviously lower value, so some data will be positive and some data will be negative. If you take this one, the sum, then what will be? It will be 0. So sum of error obviously equal to 0, but error never be 0. Okay, then you have to take the absolute value. Absolute error is the magnitude of the difference between the measure value and true value. Now how we get the true value? True value, you are taking the measurement n times measurement. Okay, average, take the average, this one, this will be the true value or mean value, and taking the absolute, the difference, this mean value or the measure value is the absolute error. We get in the absolute error. Okay, this is the absolute error, and when you take the mean of this absolute error, then it will be mean absolute error. You are taking the mean value of this absolute error, then mean value. And now if we expressed this mean value with an ratio of the true value, then it will be relative error. And if this relative error is expressed in percentage, then it is percentage error. Okay, now we move to the propagation of error. Suppose this is from the addition and subtraction. Suppose the output is some combination of two input, A and B, and if you measure value of A, we get the error delta A and B delta B, then what will be the actual value of A plus minus delta A? Error may be negative, may be positive. Okay, so obviously B will be B plus minus delta B. Now we replace this term in AB, then what will be then? X plus minus delta X equal to A plus minus delta A plus of B plus minus delta B. So if we simplify that one, that equal to A plus B, plus minus we take the common, then it will be delta A plus delta B. Now substitute here, this is X, so it will be X. Now X and X will be cancelled, so ultimately delta X equal to A plus delta A plus delta B. In this case also, this is the subtraction. Here it will be same. Here you see X equal to A minus B. This is the subtraction form. So what will be the X plus minus delta X? You substitute here A plus minus delta in place of A, B plus minus delta B in place of B. So it will be A plus minus delta A minus B plus minus delta B. You simplify that one. Okay. So here again you see X equal to delta X equal to delta X equal to delta A minus of delta B. Now here you see error, obviously it will be same side because there is no difference of the error, there is no difference, you cannot subtract, so it will be same sign. So delta X equal to delta A plus delta B. So maximum absolute error for addition and subtraction will be summation of the error, individual error. Okay, and now in case of multiplication and division, here suppose X equal to A dot B, obviously we have taken same way. Now substitute the, here error will be X plus delta X, and substitute the value of A plus minus delta B, B plus minus delta B in place of A B, and multiply that one. What will be A B, B dot A dot delta B, and delta A dot delta B. Okay, now both sides you divide this side by X, this one, and this side by AB. So here you see X divided by X equal to 1, del X by plus minus del X by X. Here del B by AB by AB equal to 1, and this by AB, BB will cancel, so delta A by A plus minus delta B by B, and here plus minus delta A by A into delta B by B. Now here you see delta A by A and delta B by B is very small, so product of delta A into delta B will be very small, and we can neglect this term. So 1 will cancel. What will be there? We are getting del X by X equal to delta A by A plus delta B by B. Okay, and here we are taking that. Here you see delta x by x equal to, in place of, you substitute del a by a plus del plus minus delta a divided by b plus minus delta b. Now take the common here a, then what will be there? 1 plus minus delta a by a, b common, so 1 plus minus delta b by b. Okay, so here this one a by b and this we are keeping, and it will be minus 1. So we know that formula, that when it will be minus 1, so expansion mathematical tool we have seen, it will be minus will multiply by here. So here it will be, here we are doing plus minus, here it will be minus plus. Okay, now it will, this one will be cancelled. Again we are repeating the, as this is small, so this term will cancel each other, neglected. Then we can write delta x by x equal to delta a by a plus delta b by b. So we conclude that maximum fractional error in multiplication division will be del x by x equal to delta a plus delta a by a plus delta b by b, and so on. Okay, now if there is a power, then here you see x equal to this one. Oh, here what will you take the log both side, then log x equal to n log a plus minus m log b. Okay, if you take the both side differentiations, and del x by x equal to n del a by a minus m delta b by b. Again we know that it will be not negative, so here you see it will be positive. So here we are getting del x by x equal to plus minus, this is the error. Now we will take one example. Here one physical quantity x that equal to a square b cube divided by c d to the power 1 by 2. Then percentage of error is given. So calculate the percentage error of x. Now x is this one. So from above formula we can write del x by x equal to del b by b plus power is 2. So 2 del a by a plus 3 del b by b plus plus means plus del c by c plus half of delta d by d. Now you multiply both sides by 100. This will this value. Now here why we multiply by 100? Because it is expressed by percentage. So here we are writing in place of this one equal to 4%, in place of this one 2%, in place of this one 3%, and in place of this one 1%. Okay, substitute the value and we are getting this one. Thank you.